This is a high school Algebra I lesson on the forms of the line. This lesson has to do with primarily the standard form of the line. The standard form of the line has these characteristics. The standard form is ax plus by equals c. Sometimes that is written with capital letters, capital AX, and it's not a real difference. This is the way I generally use it and the way I've seen the most, but both ways are acceptable. Okay, characteristics of standard form. The big thing to notice is that C is isolated. C is the constant term. A reminder, A is the coefficient of X, B is the coefficient of Y, and C is the constant term. It is isolated. That's a big characteristic of the standard form of the line. Also, to make it work well, it works best when A, B, and C are all integers and A is positive. Now, some places they don't care if A is positive or not, but I'm asking you to go ahead and make it positive because there are times when it's more convenient and you might as well get into a good habit on that one. So, the standard form of the line. The standard form of the line was the form of the line until this. Okay, the graphing calculator. The graphing calculator works on function form, which we usually refer to as y equals mx plus b, or slope-intercept form. Function form. Most graphing calculators work almost exclusively with functions. Until we had a calculator that would graph things for us, this was hands down the easiest way to do many things that are done in algebra, to graph and to other things. Now, as it so happens, I've been known to say, but not in the last decade or so, that kids really didn't need to do as much because they would always have a calculator. Well, that's just not even true anymore. The people who do higher mathematics have wised up and understand that the technology is now to the point where it can do many things. And people in higher education, basically starting with algebra when it talks with math, want to know if the person can do it. They know that the tech can do it, but they want to know if the person can do it. It's not uncommon now when going to a standardized test to be allowed to have nothing with you other than a pencil made out of wood, not even a mechanical pencil, not even an analog watch. Why? Because the people who are doing the test and qualifying you for the next level want to know if you know what you're doing. So, standard form has always been good, but now we're understanding that it's not going away like we thought that it might have because of technology. Okay, well, what does it look like? Looks like that. Here's an example. Let's say 2x plus 3y equals 10. That's in standard form. The constant term 10 is isolated. X and y both have integers for their coefficient, and a is positive. The 2 is positive. Okay, well, how would we graph from that? Okay, we're going to graph using the cover-up method. One of the reasons why this is so handy is if it's written like this, it's a snap to graph it. So here, if we take a graph, let's see how it'll go. All right, let's remember that we're going to graph by using the intercepts. That's really, pretty much easiest way to graph as far as I'm concerned. Okay, so here we've got 2x plus 3y equals 10. We're going to graph using the intercepts. Recall that the x-intercept occurs when the y is 0. The y, and so to make it 0, well, written like this, a coefficient times y. If y is 0, that whole term's just going to be 0. That's just how it is. So 0 might as well be not there. So cover it up and just do in your head. 2x equals 10. What's x? Oh, right. The x-intercept is 5. So the x-intercept is 5. Okay. Well, for the y-intercept, okay, recall that we do the y-intercept when x is 0. So written in this form, it's going to be some coefficient times 0, which is always going to be 0, so it might as well not be there. So what do we have here? 3y equals 10. You can do that in your head. Y equals 10 over 3, or 3 1/3. So how can we graph it? Well, we come up here 1, 2, 3 1/3. Come here 1, 2, 3, 4, 5. We have 2 points. 2 points determine a line. When you've got 2 points, you can draw the line. And that's it. So it's really simple to graph from standard form. That's why we prefer that the coefficients, and the constant term all be whole numbers, because, for example, if this were the equivalent equation, there's an equation which would be, let's see, divided by 4. How about this? 1/2 x plus 3/4 y equals 2 1/2. Okay, is that still the x in the place, the y in the place, the constant in the place? Yeah, but you can't do this. Or at least you can, but it's a pain. Who wants to divide in your head 2 1/2 divided by 3/4? I do not. Okay, so we take all of the simplicity, well, not all of the simplicity, a lot of the simplicity away in doing this, because it just doesn't work as well. Now I can probably do that one, but I can't do that. I'd have to think about that one. Okay. Nevertheless, this is an equivalent equation to this one. If you do graph it with a t-chart or with however you want to solve it, you will still get the same line. They are equivalent. So one of the things about standard form is there are many that are equivalent equations, and they are also in standard form. Well, this one has fractions, so we don't like it. So, for example, if I take this original one here, the one I'm dealing with first, okay, and if I multiply that times 2, multiply all the terms by 2, then I'm going to get 4x plus 6y equals 20. That is an equivalent equation. It is in standard form, and this is the graph of it. It's the same thing. Okay, we can do it again. How about times 3? Okay, well then that'll be, let's see, 6x plus 9y equals 30. Is that the same line? Yeah, it's the same line. That's it right there. It's not a different line. It's an equivalent manner to do it. This is also still in standard form. Well, how about an easy one? How about times, 100? Let's see. 200x plus 300x equals 1,000. Is that the same? Yeah, it's the same. It's equivalent. It's in standard form. It's perfectly okay. And it's still this same line. All of these are equivalent ways to write the same line. We, however, prefer, there's one preferred way, and that is with no common factors. Like if it's reducing a fraction, you could see a 4 and a 6 and a 20, they'll all divide by 2 to give you back to here. The 6, the 9, the 30 will all divide by 3 to give you back to this one. This one is the most simplified. all the common factors have been removed. Okay, so that's what we're doing when we're talking about standard forms of the line. There's going to be a lot of uses for it as we go on, but now we're learning how to do it. Here, in case you want to look at something that's a little bit neater, then that's the same thing I just said. You can pause and look at it if you need to. Okay, let's do some examples here. Okay. How are we going to take an equation, to write an equation in standard form? Okay, remember, for slope-intercept, if you have the slope and you have the intercept, you just plug it into the form. Easy. For point-slope, if you have the point and a slope, you just plug it in to this form and it's easy. Yeah, there's nothing like that for standard form. However, you can do it. Now, that's kind of an interesting thing. For those of you who lean towards geeky and want to figure it out, it can be done. But for the most part, the way to do it is go through either standard form or point slope. To get to standard form, go through either point slope or slope intercept. So here's an example, a simple one. Say we have the point -3, 2, and a slope of 1. And I want to write an equation from that. Like I say, if you just want to be super uber geek about it, you can figure out how to do that straight into standard form. I'd recommend that you use the most obvious way, which is, I got a point. Oh, I got a slope. I got a point. I got a slope. I should use the point slope form. Duh. Okay. So the point slope form is y minus y sub 1 is equal to m times x minus x sub 1. Remember, x sub 1 being the specific point. The y and the x that do not have the subscripts are the ones that survive into the equation. Okay, so what do I have here? I have the y value and the x value, and I'm going to substitute it in. So y minus 2 equals the slope, which is 1, which I don't have to write, times x minus a -3. Okay, you can put brackets there if you want. I strongly, again, urge you, go ahead and write it this way. Don't do any simplification the first time you write it. Then after that, you can simplify all the place. But yes, I know it's going to be plus, but people make mistakes doing this. If the first time you write it, you'll write it completely as it is with the substitutions being obvious. In the long term, you'll be better off. Okay. So then this would I'm going to simplify everything I can. All right. Now, oh, I don't need that. Now I'm going to rearrange it. This is point slope form. Here I'm now simplifying it down because remember with standard form I want to isolate C. So I want to isolate the constant terms. There are two numbers there that are going to go together to make my constant term, but I got to get them together all on one side of the equation to isolate them. So first thing I'm going to do is, I'll just add 2 to both sides. So that'll be y equals x plus 5. Okay, now I've got all of the constants together, but I need to isolate it. I need to get rid of the x, so I'll move the x. So this will be -x plus y equals 5. Now I'm going ahead and put it in the order that I'm used to, which is the x being first. You don't have to do that, but it's usually a little easier if you do. Okay, now then, x needs to be positive, so I'm going to multiply both sides by -1. That'll be each term will need to be multiplied by -1, so this will turn out it basically just changes every sign. So there we go for standard form. Okay? In the way that I think most people anyway think is the best. Okay? So here I've written it out a little bit prettier, if you can see that better. Okay, now let's do one that's more complicated. Okay, I've got a point, -4, -4, and a slope of -3/2. And I want a line in standard form. Standard form. Okay. So, yeah, make that a little bigger. So I want it in standard form. I have a point, I have a slope. I'm going to start with point slope form. Y minus y sub 1 equals m times x minus x sub 1. Okay, fill that in. I have both of this is my x sub 1 and my y sub 1, and here's my slope. So in here, my x sub 1, I'm going to put a -4. My y sub 1, I'm going to put a -4. When I do that, I'll say y minus, and oops, that's a double symbol. I need to go ahead and put some parentheses in there. Then the slope is -3/2. Then x minus, and again, a double symbol there. So simplify this, it'll be y plus 4 equals -3/2 times x plus 4. Okay. Now, I'm going to distribute it. This will become -3/2 x plus, oops, excuse me, minus a plus, minus minus 3/2 times 4/1. Okay, 3/2 times 4/1. There's going to be some canceling, and it's going to be 6. So, to rewrite it, there we go. Okay, so we started with slope-intercept form, and now we're rearranging, simplifying and rearranging to get it into standard form. Remember, the constant is going to need to be isolated, so I can do that. Start off. Okay. So I've moved the 4. I had plus 4. I subtracted 4 from both sides to get rid of it. And now the x is in the wrong place. So I need to add that to both sides, which rewritten will be 3/2x plus y equals -10. Now everything's in the right place, but everything's not an integer. I have a denominator here of 2. If I multiply, my wish is for that to be an integer. If I multiply 3/2 by 2, the 2's will cancel, and it will be an integer. To be allowed to do that, I must multiply every term by 2. So I'll look about it this way. So 3/2 times 2 is 3x. 2, so there's that one, and there's that one, and 2 times y is 2y, and this is -20. That is standard form. The x term is already positive, so what did we do? Here it is looking a little bit prettier and labeled. Okay. We began with point slope, worked through it to begin to peel away to get it to be in standard form. Remember, we isolated c, which is the constant term. First, we combined the like terms so that the constant term would be one term. We moved the x, Now then, we couldn't have fractions or decimals, so we multiply everything by 2 to get that, and A is already positive. So there we have changing from beginning, writing an equation from a point and a slope. The easiest way if you have a point and a slope is to use the point-slope form. The easiest way if you have a slope and an intercept is the slope-intercept form. Okay, y'all try these. And what I'd like for you to do, please, is to do these questions right here. Okay? So, and I've just done 11 and 15. So to the rest of them, go ahead and write it. All of these have a point and a slope, so I recommend that you start with the point-slope form and then convert it to standard form. Please pause the playback, and when you're done, I'll have the answers for you. Okay, here's the answers. Hopefully you're getting them good. Okay, next up, let's talk a little bit about these lines that just don't fit any of that. We had that on one of the ones we did before. Let's look at what this looks like, okay? The vertical lines and the horizontal lines just don't fit very good. There's a couple of different ways to think about it. The way I generally think about it is I'll look at it and say on this red line, this is the point 4, 0. Let's see. Oh, I'm sorry. This is the point 4, 0. I was looking at the wrong place. That's 4, 0. That's 4, 1. That's 4, negative 1. That's 4, negative 2. That's 4, negative 3. That's 4, negative 4. You know what's the same thing here is the x is always 4. The y changes, but because it's a vertical line, it's always going to pass right through the point here where it's x equals 4. And all the way up, it's going to be 4 units away from the y-axis. The one thing that we can say about this line is that x equals 4. That's the equation for it. And as when we talked about slope, we can't really find the slope of this line. It's undefined, or it's infinite, or there's no slope. So trying to put it into a form where you got to put in the slope, you're just going like, and it doesn't work. Okay? So just look at it and say, what do I know about the line? Step back and just investigate it independently. Say, well, I know that no matter where it is, x is 4. That's the equation. Okay, that's the red one. And then down here, what can I say? Now, this one you could do a slope on, because you can get the slope of that. The slope is 0. So if you wanted to use, you can see that the slope is 0. If you wanted to use the point-slope form, you could. And what you'd get is, well, we'll use this point. Okay, and so that'll be y minus y sub 1, which is negative 4, equals 0 times, who care what it is? It's 0 times it, it's going to be 0, whatever it is. Actually, it's, you know, something else. So here we have y plus 4 equals 0, or y equals negative 4. So you can actually use the formula to get this. Now, it's not going to look very good, and if you're going to do it, you should probably actually put this in, which would be x minus 2, but it's times 0, it's still going to be 0. So what do we see here? We see here, for the vertical line, x is always the same. And for the horizontal line, y is always the same. And that is what the equation of the line is. But you say, Miss, it just says y equals -4. Yeah, because every place on that line, y equals -4. Doesn't matter what you put in for y is always going to be -4. So let's mention here and just notice for a moment. Okay. A little bit here. Down here when we're looking at these at the bottom. Okay. Horizontal lines and vertical lines. Write the equation of the horizontal and vertical lines that pass through the given point. Okay. So, the horizontal line, it's always going to be the same y. So here if we have 3, 2, remember what we just did. The horizontal one always has the same y. It's the y-intercept, it's the y wherever it is, and it's just y equals here, -4. Well, since I know that y is 2, and it's a horizontal line, then the equation must be y equals 2. Okay, and so for this one, it's a vertical line, and it goes through 3, 2. So see, this point would be like 3, 2 would be like right here. A horizontal line passing through here is always y equals 2. A vertical line passing through the same place is going to be, what? X equals 3. This is going to be the vertical, and this is going to be the horizontal. And now, you know, a lot of times we just overthink this and try to make it work because we think it's hard. And in some sense it is hard, but you've been keeping up with me to this point, and you know, you can do it. So let's look at this one. It's listed as 24 here. It's -5, -3. What's the horizontal line? Well, it's going to be y equals -3. What's the vertical line? Well, it's going to be x equals -5. Hopefully you're seeing the little pattern here. Okay, if it's a horizontal line, it's always going to be the same. You know one of them, they're all that way. So that would be the case for each one of these. Okay. Here endeth the lesson. We continue with a small summary that will be short, and otherwise, thanks for listening.